Okay, so keeping things very simple, so simple that a kindergartner couldn't understand. I have here the principle of spherical celestial objects and the diameter principle of stellar evolution. Here you go. I'll link these two papers in the bottom. They were written in 2016, or this one was written in 2016, and this one was written in 2018. You can see how big of a time gap between the ideas occurs. I mean, there's just so many things. It takes years and years for me to fully work everything out and come back to it. Years and years. The vast majority of celestial objects are oblate spheroids, meaning mostly spherical structures. These objects, astrons, number into the hundreds of billions per galaxy. To answer Adam Lohr's question, how many water worlds are there? I think I responded with 6.4 trillion water worlds in the Milky Way galaxy. Their evolutionary timelines can be inferred as mostly spherical as they evolve because gravitation keeps them around. That's very simple to understand. This means any theory that relies on disc-shaped structures to determine the evolution or the formation of mostly spherical structures is probably misguided. The principle is stated below. Gravitation keeps objects mostly spherical as they form and evolve. This means if a celestial object is not mostly spherical, then some other force is dominating or has dominated its actions. This includes string-like objects, filaments, torus-configured objects, objects which emit or eject streamlined jets of matter, oddly shaped objects, etc. Clearly, there are events in the universe which ignore gravitation. It's true that some things ignore gravitation. They're so energetic, they're so weird. As well, it means that some event which ignored gravitation occurred, as is evidenced by oddly shaped asteroids. It is made clear that they are more than likely the impact remains of two celestial objects which have escaped the mutual gravitation of the parent bodies, such as Comet 67 Papa. There's a little picture of it. It's like a rubber ducky shaped asteroid. So basically what happened is, to explain why this thing is so weird shaped, is that, say for instance you have a fluid and you slam into it with like a rock and it makes a splash. All the splashing particles that leave are not all spherical themselves. Some of them make dumbbell shaped orientations because they're two spherical shaped objects that remain stuck together as they exit the impact event. So they just orbit like this are really fast, and they leave the origin of the impact. And that's why we have bilobed shaped asteroids. It isn't because two large asteroids clump together in outer space in the vacuum. That's retarded. It's just one object. The minerals and rocks on one side match perfectly the minerals and rocks on the other because they came from exactly the same place. And the reason why they're duck-shaped is because they became molten and they solidified in outer space after they left the impact event. So the impact that can make something as huge as Comet 67P definitely was gargantuan, definitely beyond our capabilities in producing, nuclear weapons and stuff like that. But basically, the reason why I want to tell the spherical thing out is it leads into the diameter principle of stellar evolution. Now, I have here, piggybacking on the principle of spherical celestial objects according to stellar metamorphosis, a new principle is presented to make predictions of not yet discovered stars. The changing diameters of stars is continuous. And what I mean continuous is, you'll see here, the nebular hypothesis and all accretion theories that have no explanation as to why stars are found in all diameters. In fact, all diameters of stars are going to be different because they are all in different stages of evolution. No star is the exact diameter of another, as well it is continuous. A picture is given below to explain what the diameter principle means and how powerful its predictive power really is. So I drew this freehand but I measured it out. You can read this for yourself. The lined one is predicted, the blank one is observed, and then I have it in Earth diameters. So if you observe these blank little circles here, the diameter principle means is that you are 100% going to find objects that are intermediate in sizes between the ones that we have observed. So these are going to absolutely 100% exist. That's the prediction. And the reason why is because it's a continuous. Stellar evolution isn't a what would be called stepped or quantum type process. It isn't the star is 5 Earth diameters and then it evolves within a few days and then boom becomes 4.5 Earth diameters. No, it doesn't work like that. It goes from 5 and continuously down on a digital scale versus analog. And I mean, I got that backwards. It goes on an analog scale versus digital. So think of like when you turn a radio knob, like the old school radios before, you could have buttons on the radio. You could turn it and you could make adjustments, very, very, very slight adjustments. And every single little slight adjustment, there's going to be something there. There's going to be a specific frequency there that's completely unique. And that's what I'm saying here is that the diameters of all the stars, which evolve all the way down past Earth's stage of evolution, are all different because every single star in the galaxy is unique, regardless if they all have similar evolutionary lines. And think about that for a second. Human beings grow similarly in the womb, and we operate similarly, we talk, we look around, we think similarly. But every single human being is unique. No human being is exactly the same size as another. We all have different masses, we all have different heights. Think about it like that. Every single person is unique, every single star is unique. That's what diameter principle is telling you. As well, when you see information, keep in mind that it's not as exacting as we would want it to be. So a number is just tossed out there. For instance, Kepler 1349 Bravo and Kepler 1339 Bravo, each one has a radius of 0.69 to 0.71 Earth radii. Now, what that means is, of course, it's not exactly 0.69 Earth diameters. It's not exactly 0.71 Earth diameters. There's a lot of on the other side, like to the thousands, to the 10,000s, to the 100,000s. You can be a lot more exacting with it. But of course, from a layman's perspective, or somebody who doesn't understand, that doesn't exactly mean that theirs is exactly the same size as well. If you see objects like Kepler 378 Charlie, Kepler 141 Bravo, and Kepler 1349 Bravo, which all have radiuses of 0.69, 0.69, 0.69, 0.69, that doesn't mean that they're all exactly the same size. No. It's more like I have this paper like 0.6902 and then 0.693 and 0.691. They're all different. They have all different diameters, and that's very important to understand because there are just so many of them. I would bet, if you take 0.69 to 0.689. In between those two numbers, there are probably at least 1 million objects in between those two sizes. And that's extremely exacting. And that's what the diameter principle is telling us, is that when the astronomers, they look at these objects, the nebula hypothesis has no method for predicting that they're all going to be different sizes. Remember, the nebula hypothesis isn't even a theory. It's not and it's a hypothesis that has been falsified repeatedly over many, many, many years, many, many decades. Every single bit of information that comes out disproves it, but it's still kept for reasons unknown. Anyways, I just wanted to share this with you guys, and that the stars, they're all unique. They're all in their own unique stage of evolution. No star is the same exact age. No star is the same exact diameter. No star is the same exact mass. They're all unique, but they all have similar lines of evolution. And that's basically it. Okay, you guys, I'll go ahead and link this to the bottom. It's very simple, and the reason why I wanted to keep it simple is because the astronomers, they've gone off the deep end. They're sitting here looking at what they would call a protoplanetary disk and saying somehow a disk becomes spherical objects. It's not needed. No disk is needed at all. All a disk is a debris field. It's when two objects had slammed into each other, and then that material just kept on orbiting around the star, creating a big disk. That's what creates rings around the stars. And sometimes the rings are just really freaking big because the objects that slammed into each other or have disintegrated are really large. That's all a protoplanetary disk is. It isn't a field where a planet's forming. Not at all. The star creates the planet in its internal regions and shrinks, decreasing in diameter as it evolves over many hundreds of millions of years. All right, guys. I guess that's enough. Later.